Assalamualaikum and hi everyone. My name is Farhati Shakia binti Solihin and my matrix number is 06DKA24F1085. So today I'm going to show you guys and explain the fundamental principles and application of momentum in pipe flow analysis. Introduction. The fluid mechanics studies how fluids such as water or air move and how force behave within them. One of the most important principles used in Newton's second law, which state that force is proportional to the rate of change of momentum of an object. So, when applied to fluids, this becomes the momentum principles, allowing the engineers to calculate the force produced when a fluid change its speeds or direction, such as in pipe bands, elbows, nozzle, or water jets. By understanding and applying these principles, engineers can predict the force exerted by flowing fluid and on surface or structure and design safe and efficient system. So next, we move to the Newton's second law in fluid flow. As fluid moves through a pipe or across a surface, its speed and direction tend to change. This change leads to a variation in momentum, which then create a force acting on the pipe walls and also system components. To find this force, we use the momentum equation, which is F equals to the difference between outlet and inlet velocity. And M here represent the mass flow rate, and it depends on the fluid density, cross-sectional area, and also velocity. So for a simple example, let's consider a pipe band that turns water 90 degrees horizontally. The water has a density 1000 kilogram per meter cube, and the flow rate is 0.01 meter cube per second, and the velocity given is 5 meter per second. From this, we can calculate the mass flow rate to be 10 kilograms per second since the flow velocity is 5 meters per second. And the direction change by 90 degrees. The momentum also changed direction. As a result, the pipe band experienced a force about 50 newtons due to the momentum change. This simple example shows how a change in flow direction can create noticeable force on pipe components. Next, let's move to the momentum principles. The momentum principles is a fundamental concept in fluid mechanics. It connects the external force acting on a system to change in momentum of the fluid. In fluid flow, we cannot isolate a specific mass, so we use a special form of the equation for continuous flow. According to Newton's second law, any change in momentum is caused by a force, and this change occurs in the direction of the force. And also simply put, whenever the fluid speed or direction change, a force appears on the system. Momentum in designs. First is pipe bands and elbow. Second is hydraulic structures. So first, when fluid change direction, it exerts side force. So engineers calculate this force using the momentum principle to design supports and anchor. Next, hydraulic structure, such as spillways, deflector, and also baffles. It used in dams and drainage system to safely dissipate water energy. Momentum helps design deflector to redirect flow and reduce erosion, and also ensure stability and durability of civil structure. For example, a diameter of 48 millimeter water jet has a velocity 12 meter per second. It strikes a flat pipe inclined at 60 degree to the axis of the jet. Calculate the resultant force on the plate. So the question is, if the plate is static and also the plate is moving with a velocity of 7 meter per second along the jet. Start with the diameter of the plate, which is given as 48 millimeters. Since there are 1000 millimeters in 1 meter, we convert it by dividing by 1000. So the diameter of the plate in meter is 0.048 meters. Step 2 is we find the area of the circular plate using the formula for the area of a circle, which is A equal to pi d square over 4. So the area of the plate is approximately is 0.00181 square meter. Finally, we calculate the force exerted by the fluid using the formula F equal to density times by area times by velocity square and since theta. Substituting all this value into the equations, so the force acting on the static plate is 2025.714 newtons. To summarize, we convert the diameter to meters, found the area, and then use the fluid force formula to determine the force acting on the static plate is about 226 newtons. So next, the plate is moving with a velocity of 7 meters per second along the jet. So when the plate is moving along the jet, we must use the relative velocity between the jet and the plate. So the formula becomes F equal to rho, which is density times by A, and V minus by U squared. And also don't forget the sin theta. So substituting into the equation, and we got 39.18 Newton. So the force acting on the moving plate is 39.187 newtons. Compared to the static plate case, the force is much smaller because the plate moves along with the jet and reducing the relative velocity of impact. So next application in pipe bends and elbows. The concept here is when a fluid flows through a pipe bend or elbow, the direction of velocity change causing a change in momentum. According to Newton's second law, this change in momentum produces a reaction force on the pipe walls and supports. So in real engineering case, first, piping in power plants and refineries. Second is hydraulic system in dams and treatment plants. Third is firefighting or irrigation system. So first, its support and anchor must withstand large momentum force. And the second one is require proper anchorage to prevent pipe movement or failure. The third one is momentum analysis ensures safe design. So for the conclusion here is Newton's second law forms the basis of the momentum principle in fluid flow. So any change in fluid velocity causes a force that must be considered in design. And also momentum analysis help engineer calculate force in pipe bends and jet. It ensures safe, efficient, and stable engineering system. Thank you, that's all. So next we are going to the Q&A session.
Why do engineers use the momentum principle when designing pipe supports and anchor?
So thank you, Jia, for the question. Engineers use the momentum principle to calculate the side forces created by changing flow direction so that allowing them to design proper supports and anchor to resist these forces.